So, welcome everyone. Our homework was to use the MATLAB's vehicle dynamics model and make a parallel simulation with SUMO. The content is the initial steps were to create or download the freeway, and we choose the M5 freeway, more precisely a section of it, which can be seen on the picture. The distance is about 4.5 kilometer long between the starting and the finishing edge. The next step was the controller itself, the longitudinal controller, and calculate the resistances acting on the vehicle, such as the aerodynamic rolling and ascent resistances. And finally, the evaluation. We created a sort of a realistic situation when we increasing and decreasing the velocity led the vehicle to roll out and in emergency brake. So in the last section we show the result of this example. So the first steps was to download road or freeway section. So we download it in OSM5 format, then we import this file using the netconvert command. We created the net.xml file, and using the netedit we can open this file now, and we can see the map, and we can choose and this is how we can choose the road section. We choose the proper edge IDs to where to start to where to end. So we choose this 4.5 kilometer long edge, which can be seen on the picture. So at the first place we tried to get the parameters from SUMO, in example the slip of the tires, the steering angle, the lateral velocity, and based on this calculate the longitudinal velocity, what we can give the car in SUMO as an input. But unfortunately we can't get these values, there is no function for it. So we created the longitudinal controller where the inputs are the throttle and the brake pedals, and by using this we can control the speed of the vehicle by using only these two pedals. So the longitudinal controller in Simulink, we calculate the thrust based on our pedal positions, which are equivalent to the torque on the tires. In example, we push the throttle pedal 100%, we multiply it with one constant, let's say 3. This means that we apply 300 Newton meters of torque on the tires. So the torque divided by the radius of the tire, we get the proper force we need, and we calculate the resistances as well, which are against this thrust. Then we get the final value of the force, what we divide by the mass, then we get the acceleration of the car. So when we have this value, the acceleration, and integrate it, we get the velocity of the vehicle, which we would like to send to the SUMO, and this is how we control the vehicle. So this is what it looks like, our Simulink model. On the top left corner you can see our sliders, which are representing the throttle and the brake in a percentage between 0 and 100, and we multiply these with constants to get the proper realistic torque and the braking torque values. For the tire models we use the so-called magic formula. So the last step, the evaluation, we simulate a realistic driving scenario where we use these two sliders, and we get 300 Newton meters of torque and 600 Newton meters of braking torque. These are the maximum values. And in this example, you can see the first phase is about 15 steps when we push the throttle 50%, and after this phase we push the pedal 100%, and the third phase was a rollout test when we didn't push any pedals, just let the car to roll out. And after this we did an emergency brake test, and when it's almost stopped we give a full acceleration again. So this was our example, our test, which can be seen on the video on the next slide. So in the middle you can see the car in SUMO on the M5 freeway. On the top right corner you can see the acceleration. On the bottom right corner you can see the velocity of the car, and the bottom left corner you can see the torque, which is our input. The yellow line is going to be the throttle and the blue is the brake. So the test was 100 steps and the time step is 1 second, and we pause the simulation with 1 second as well. In this way we can control it more precisely. So let's start the video. So at the start we use the 50% of throttle, and after about 15 steps we go all out. We go all full throttle, which can be seen now. The velocity is increasing as well, and when we reach about 40 meters per second velocity, which is a little bit high in this freeway, and we do a rollout test now. So we do a rollout test. You can see the torque is 0 and the velocity is decreasing. At this point we will do an emergency brake test right now. You can see the velocity is decreasing even more as we accept, and when the car is almost stopped we did a full throttle again. So this was our test case. The maximum acceleration is 1 and the minimum is 2.5. It can be a little bit higher, so we should increase the braking torque, but for an older car it can be a realistic value. So in this homework we use only this straight section of the freeway, but with this controller we can control the car speed in real time, so we can choose any other road section as well. First we tried to use only the MATLAB, not the Simulink, but this is a better solution because we can control the speed in real time. And thank you for your attention.